Good afternoon, everyone. Now, GATE 2026, Set 1 paper has been finished, and we are going to start the discussion of Set 1 2026 Computer Science paper. We have asked these questions from students. How do you feel about this particular paper? So, what kind of opinion I have received till now? There are 29 students have been responded till now, and out of 29 students, 20 students they are saying that this paper is moderate, and 9 students are mentioning this paper is easy. So if we'll go with the data points, so roughly 2 by 3 students they are saying that it is a moderate paper, and 1 by third saying it is a easy paper. So I would go with the majority, and I would say that this paper possibly from easy to moderate means those students who have not practiced well, definitely they will find that this paper is slightly complex side. But those who have regularly done the practice, they will find that this paper is easy to moderate. Having said that, I received few of the problems from one student, and all these problems are a memory based problem. So the first problem, in a 4 cross 4 matrix, each elements can be either 0 or 1. How many matrices can be formed such that every row and every column has even number of ones? So this problem can be solved in a 2 different ways. First, I will explain about the simplest approach to solve this particular problem, and we will show you also, right, some smaller size of a matrix, and then you can feel it. If you look at, right, the students whom I have taught, if there are n elements in a set, how many different subset we can select such that we have an odd number of elements selected or even number of elements selected. So what I always mention, for n minus 1 element, there are 2 choices. So 2 raised to n minus 1, the last one is a fixed, right? It could be, if it is a right even, you want to select. If up to n minus 1 it is odd, then it will be 1. And up to n minus 1 it is an even, then it should be what? 0. Probably this thing I discussed is just only last lecture here. So what you can feel here, if there are 4 cross 4 matrix, how many matrix? 4 cross 4. So for 3 cross 3 matrix, for 3 cross 3 matrix, you can take any entry as per your choice. You can take any 3 cross 3. I will show you, right. So let's say I have taken 101, 110, and 0. Or you can say here, everywhere it is a 3 ones. Yes or no? So this is some independent math. I can explain you here the fourth row and fourth column. The entry does not have a freedom. How it is? Here there are two ones, then this should be zero. Yes or no? Here there are two ones, so this should be again zero. Here there are three ones, then this should be odd. Yes or no? So if it is odd, then this should be one. Yes. Now look at this. There is odd ones. This should be what? One. Here even. It should be again like zero. Even. It should be zero. So this is odd and this one is odd. So this should be what? One. So if you look at here, there is a choices for only what? 3 cross 3 matrix. Yes or no? The fourth row and fourth column is a fixed. Fourth row and fourth column is a fixed. So in 3 cross 3 rows and 3 columns, how many total choices? 9 choices. How many choices? 3 rows and 3 columns. So how many distinct such matrix is possible? 2 raised to 9. How much it is possible? 2 raised to 9. You can feed the same problem in a other way round also. This problem you can feel in a other way round also. Look at here. You have a 4 rows. Yes or no? Understand the modulo 2 concept. Sum of the rows divided by 2. Divided by 2. Either remainder will come 0 or remainder will come 1. Yes or no? There are only two choices. There is no other choice. Yes or no? So now if you look at here, so for each row, there are two choices. How many total number of 4? 4 rows. How many rows? 4 rows. So how many choices? 2 raised to 4 choices. 2 raised to 4 choices. How many we have a columns? 4 column also. We have a 4 columns also. So for row, first row 2 choice. It could be either odd or it could be even. Second row, how many choices? 2 choices. It could be either odd or it could be even. So 4 rows. Yes. The same way 4 columns also. The same way 4 columns also. So you will have how many total number of rows and initial column? 4 rows, 4 columns. So total 8. Total what? 8. But if you look at out of these 8, when all 4 rows are even, as well as all 4 columns are even, yes or no? These are one and the same. No? This has been counted twice. Agreed or not? So you will have a same in choices. How many choices? So you can simply subtract, right? Total there are 16 elements, right? In 7 cases it could be odd. 7 cases it could be odd. So how many cases left out? 9. So 2 raised to 9 elements. How much? 2 raised to. I can show you. Let's say there is a 2 cross 2 matrix. What is a 2 cross 2 matrix? I'm saying only there is a freedom for 1 cross 1 matrix. There is a freedom for what? 1 cross 1. So 1 cross 1 matrix, what entry could be possible? Either it is a 0, just wait, or there is another choice. The first element 1 cross 1 is 1. Now look at. If it is a 0, and each row and each column an even number of right ones, then this should be 0, yes or no? And these two are 0, so this should be 0. Agreed or not? The same way, if this is 1, then this should be 1. And if this is 1, then this should be 1, and this should be also 1. So there are choices for only 1 cross 1. There are choices only 1 cross 1. In the same way, if you random take any 2 cross 2 matrix, let's say 1, 0, 0, 1. So if someone want to check, right, what is the choices for 3 cross 3? So since it is odd, then this value is 1. This is odd. This value will be 1. Now it's odd. This value will be what? 1, odd, 1, even. This value should be 0. Yes? So for n cross n matrices, to be the sum of each row and each column is even, right? you have a freedom to n minus 1 cross n minus 1 matrix. Yes, it means total freedom is a 2 raised to n minus 1 square. How much it is a 2 raised to n minus 1 square. So here n is equal to 4. So that answer is 2 raised to 3 square, which is 2 raised to 9. How much it is a? So 512 such matrices possible. So answer for the first problem is 512. Everyone understood? So how many total choices? 2 raised to 16 minus 1. Okay. So now we'll come back to the second problem which I had. Okay. So there is a problem here. We have a min heap of n elements where n is an odd number. N is an odd number greater than 100. Indexing starts from 1. Indexing starts from 1. Means the root element position is 1. Root element position is a. So which of the following is not index of a leaf element? Which is the following is not index of a leaf node? They have asked the question. Now look at, I told you every one of you, because there are total n elements. Min heap of n elements and n is a odd number, n greater than 100, indexing starts from 1. Which of the following is not index of a leaf node? Okay. So now please everyone understand what is the method. If root index starts from 1 and you have total n elements. So how many elements? N elements. So the position if there are n elements, the position of last parent is floor value of n by 2. The position of last parent is what? Floor value of a last parent in bracket internal node floor value of a n by 2. Floor value of a n by 2. Right. So and n is odd we know. Basically, in simple way, in n terms, we can say it is a n minus 1 by 2. How much it is a? By 2. That is a n minus 1 by 2. Let's say 101 elements is there, right? So 100 fluoraphan by 2, that is 50.5, and then 50. So simply we can say n minus 1 by 2. What we can say? N minus 1 by 2 is a last internal node. It is a last internal node. It means any element's index less or equal to n minus 1 by 2, that will be internal node. That will be without. Less or equal to n minus 1 by 2 internal nodes, and more than n minus 1 by 2, I'll consider this as a leaf node. What are the options here given? Option, it is a memory based option. My option could be wrong also. N plus 1 by 2, B, n minus 1 by 2, C, n minus 3 by 2, and D, n. So they have asked not index of a leaf node, not index of a leaf node. Means they are asking index of whom? Internal nodes. They are asking index of a internal nodes. An index of internal node is less or equal to what? N minus 1 by 2. So I feel that it should be then MSQ problem, and correct answer should be n minus 1 by 2 as well as n minus 3 by 2. So for 101 elements, how many elements? 101 elements. N minus 1 by 2 is 50, n minus 3 by 2 is 49, and both must be internal node. I want those students who appear the examination, if there are some difference in understanding, so please correct the problems in a chat window. If any one of you have any kind of a doubts. कैसा भी प्रश्न 50 50 for n is equal to 10 पढ़ने में कमी दिख रही है चीजें कुछ भी आपने काम कर now I have one more problem here. They have asked one question. Pre-order sequence of BST binary search tree is given. what will be the position of a 60 in a post-order traversal? There is a binary search tree which pre-order traversal is given in the problems. Complete problem is not there. There is binary search tree. Pre-order traversal is given. And they have asked what will be the position of a 60 in a post-order traversal. I don't have complete problems, but I can explain you the method to solve it. You have given a pre-order traversal. You sort that list, that is in order. Any PSC can be uniquely constructed then, yes, with the pre-order as well as in order. Once PSC has been constructed, you just take its what? Post-order traversals. What you can mention? Pre-order traversal is given. Sort those elements that will be traversal of a post-order. That is a traversal of an in order. You are given BST pre-order traversal. Sort those elements. You will get the traversal of a in order. BST can be uniquely constructed. BST can be uniquely constructed using pre-order and in-order traversal. Okay. So now, once pre and in is given, you have able to construct the tree. With pre and in-order traversal, we can construct the tree and then take the post-order traversal. Then take the post-order traversal and you will find the position of 60. Okay. 60. Okay, now next problem. I have some memory-based problem I received. You can correct the problem because the source is only one student. There is an NFA of 6 state. Which of the following states are not possible in corresponding minimized DFA? Minimized DFA. So there are 4 options are given. A 65, B 120, C 64, D some value which is less than 64, not remember. So you can write less than 64 somewhere. So question is very simple. If NFA has n states, then DFA will have maximum 2 raised to n states. If NFA has an n states, then DFA will have maximum 2 raised to n states. It means if there are 6 states in NFA, then DFA will have a less or equal to 2 raised to 6. Then DFA will have less or equal to 2 raised to 6 states, which is 64. 2 raised to 6. It means minimized DFA will have a less or equal to 64 states. Less or equal to 64 states. It means if that is the correct question, so two options are right, cannot be corresponding minimum DFA. One is a 65, another is 120. This is not possible in a minimized DFA. So just wait, we are waiting for some more few problems for the discussion. Any students who have questions, they can send into their message.
Can you please check WhatsApp?
So now I have received some more responses and couple of problems from students. But before that, there are many students who are interested to understand the complexity of this paper. So what response as of now I got, that is a close to exactly if I'll go 52 response, and out of 52 response, 43 students they feel that the paper is moderate, and there are 9 students who feel the paper is easy. So that is 43 and 9. So roughly, if you take it, 80% of the people they are feeling that the paper is moderate. And if you'll ask me, what are the problems I have received? I would also say this paper was definitely difficult than a set one of a gate 2025. Definitely set one of a, there is only one set gate 2023. Uh, as of now, I cannot clearly say because I have hardly 5 to 6 problems. We need to check right whether it is a like of a set one and set two of a 2024 or even a bit more difficult than it. But two statements are very clear that this paper is definitely difficult than a 2025 set one paper. It is a difficult than 2025 set one and 2023 paper gate CS. 24 as of now with the such information I cannot comment, but slightly I have a feeling that this paper was a slightly could be either equal or more difficult side of 24 set 1 as well as set 2 also. I'll take not the name of the students, but uh, these are the some good students actually. Uh, of course, it is better than average, but I have seen the students who has mentioned the number of problems attempted. There is only one student of mine who mentioned as of now, out of some 12, 13 responses, that he has attempted all problems, 65 out of 65. Another one who mentioned there are 61 problems. Then two students has mentioned 59 problems, 158, 157, 156, and 155. So roughly right, the attempts 55 to 65. And normally I encourage the students to attempt more problems. But since majority of them are going right 55 to 60, so this attempt also shows paper was slightly moderate towards hard rather than easy to moderate. So definitely it was not easy, that is 100% sure. Easy to moderate, some chances moderate, or it could goes to even a bit of a moderate to harder. While none of the students still now have reported that the paper was difficult. So let's come back to a few more problems. So one feedback, there are many problems of a graph theory, but exact problems I'm not able to find. A few of them, if I can find, just let me check. So there is a problem on MST, but complete options are not mentioned. Problems of a MST. What is the, there are options are given and asked which of them are true. The first one is the large, consider a minimum spanning tree with unique edge weights. Means I'm considering then there is a graph where all age weight are distinct and real and positive, while in this problem it is not mentioned real and positive, but generally it is a, which of the following are true? The first statement is the largest weight of every cycle is not part of any MST. This statement is a true. For any cycle, its largest weight cannot be part of a minimum span. The option is one and the same what I have spoken. The largest weight of every cycle is not part of any MST. That statement is true. And you can look at the K25 notes, right? It has been discussed. Similar problems have come in PYQs also. That's why I'll always recommend, right? You should be more focused on a PYQ. Second one is the lightest age of every cycle is a part of every MST. This option is again further false. This option is false, and this has been also bring from the previous year PYQ only. Let's take an example, very simple example. I'm constructing graph here. 1, 2, 3, 4. If you look at it, 4, 5, 6, 7. There is a cycle of 4, 5, 6, 7. There is a cycle 4, 5, 6, 7. Where 4 is the lightest weight, but it will not be part of a MST. Why? Because 4 is the highest weight in some another cycle. So 4 will not be definitely part of a MST. 4 will definitely not be part of a MST. So the second options seems to be that is incorrect. First option is correct. And the students who have posted this problem has mentioned that he or she did not remember the third and fourth one. So if this problem is MCQ problem, then option is very simple. The first option is the correct one, right? And
It was MSQ problem, sir.
okay, it is MSQ. Okay. So other two options, I'll try to get it. So now I have right Other two options are also available. That is again, I'm telling again and again, this is a memory based. So if the students are not able to remember the correct questions, so we may discuss the wrong answer also. So please, what are the other options I received? There is a vertex U, all edges which are incident on U, all edges which are incident on U, the heaviest one will not be part of MST. Will not be part of MST. Again, this statement is a false part of MST. So this is a false. I'll tell you the example. If you take a simple graph, a triangle, so on the vertex B, the heaviest edge which is incident on it, that value is 2. But here 2 is a part of MST. 2 is a part of MST. Heaviest edge 2. Incident on vertex B is part of MST. So option B, which is mentioned that heaviest edge should not be part of MST, that answer is false. Now D, which is actually the concept of a light edge. On every vertex, the lightest edge incident on the vertex will be part of MST. Lightest edge incident on a vertex will be part of MST. This statement is a correct one. This statement is a correct one. And that is known as a light edge, right? For every cut, the light edge is always part of a minimum spanning tree.
So I think it said that the lightest weight incident for every vertex is a part of every MST. I think that's what it said.
Yeah, every MST. That statement is also true
Yes.
because it is a mention that all edge weight are distinct. Since all edge weight are distinct, so on each edge, the lightest edge weight must be distinct. And if it is unique, then it is must be part of MST. If the question would have been repeated edge, right? Maybe there is two edges, weight is one. Both should be present, that is not necessary. So there are a problem related to the database management system. R is a relation which has 4 attributes A, B, C, D. R is a relation which has 4 attributes A, B, C, D. The candidate keys are AB. AB is a candidate key and AC is a candidate key. Then how many super key possible? Such problem I discussed in number of times. And you may find the even exactly same problem also, exactly same problem also actually in this one. So the ask is very simple. When you take AB as a candidate key, then there are 2 attributes left out, what? C and D. So there are 2 raised to 2, 4 super key. Once you take AC as a candidate key, then again 2 raised to 2, that is a 4. Here few of them is repeated. Those super key where ABC, all of them are part. So that is 2 raised to 1, 2. So correct answer is 4 plus 4 minus 2. So the answer goes to 6. There are 6 super key possible. And if you want a name of those 6 super key, I can say AB, ABD, ABC, ABCD, and then AC and ACD. These are the only 6 super key. So please note it down. There are 6 super key possible. So this particular problem, I consider that it is an easy problem, right? Not very, very easy, but definitely right. Those who have prepared it a bit seriously, then definitely they can solve this problem. Now, related to the functional dependency, there is one more problem has been asked, functional dependency, and that is MSQ problem. Memory based 3 options are given. 4th option is missing as of now. So what is the problem? Select all true statements. Select all true statements. So the first one is, if P implies R, means P derives R, and Q derives R, then PQ derive R. Yes, this statement is definitely correct. Yes or no? If P itself closure include R, right? Then after, and even Q in closure include R, definitely PQ closure will also include R. So this statement is a true statement. Second one is, if PQ derive R, then P derive R and Q derive R. This is a false statement. Closure of PQ includes R. P need not to be include R, or even Q need not to be include R. Okay. There is a third option. So second is a false statement. Now, third, if PQ derive R and P derive R. So of course, if P derive R, then PQ derive R, right? But what they mention, then Q derive R. No, this is false. It is a P who derive R. PQ combined derive R. It does not mean that the Q alone can derive R. So the third statement is also false. I do not have the data related to the fourth statement. I'll try to some student. So one problem of aptitude we got just now. A dice has been rolled twice. A dice has been rolled twice. What is the probability? Second outcome is multiple of a first outcome. So look at here. If the first outcome is 1, then it has 6 multiple. Second, if the first outcome is 2, then it will have a 3 multiple. If first outcome is 3, then it has a 2 multiple. And for 4, 5, and 6, we have just only 1 multiple. I'm considering they have not mentioned the 2 outputs should be different output, right? So if the sum is 6, 3, 9 to 11, 3, 14. So total probability is a 14 by 36, which is a 7 by 18. Probability is a 14 by 36, and which is a 7 by 18. So we'll of memory based graph. So first we'll draw the graph and then we'll discuss it.
It's not arrow, it's a minus sign actually.
So look at for this problem. This is pretty simple problem. How to check such kind of problems? There are critical points. There are three nature of function. One between 0 to 10, and then the nature of function change from 10 to 20, and then post 20 also it will change. So first you check, right? Between 0 to 10, the final answer should be what? 0. Look at here what it is mentioned in the function. Hk of s is the max of a s minus k comma 0. So till k will not exceed, till the point will not exceed, right, the value of 10, value of a 10, the value will remain the 0. So here look at between 0 to 10, because the function is defined on 10 as well as at 20. Yes or no? So h10 will be 0 till we will not cross the 10, and h20 will be 0 till we will not cross the 20. So 0 minus 0, the value will be 0, right? So 0 to 10, the value should be 0. That is the correct one. Now look at here. After h20, after h, a point of 20, the value remains the same, and that value should be 10. That value should be what? 10. So what if you look at here, h10 is nothing, right? It is, let's say x equal to x minus 10 is what? X minus 10. Agreed, everyone? So at 20, this value will become what? 20 minus 10, that value will become 10. Now, let's say you are calculating for 25. So for 25, h10 will be 25 minus 10, 15. And h20 will become 25 minus 20 is a 5. And 15 minus 5 is a 10. 15 minus 5 is a 10. So the correct answer for this problem is a B option. Which option is? B option. H10 of S minus H20 of S. Minus H20 of S. But H20 will be 0 till 20. H10 will be 0 till 10. So till 10, none of them are effective. So answer is 0. 10 to 20, only the function 10 is effective. Then answer is right. The value minus 10. And after 20, even both will be effective, right? But after 20, right, H20 and H10 will cancel out each other. Yes or no? So whatever is this gap of 10, that will be only the constant gap. So the answer for this problem is H10 of S minus H20 of S. So you can mention, right, for point number 5, H10 5 minus H10 20, H10 5 minus H1020 is equal to 0 minus 0, that is 0. For point 15, H1015 minus H20 H2015. So this value will become 5 minus 0, 5, that is correct. And H at point 25, 15 minus 5, that value remains the 10. So correct answer goes to B. So now few more students have come here. So we'll check with them, right? What are the some other set of at least couple of problems, and we will start the discussion on. So in aptitude, there was a problem. There are three players: Neeraj, Jacob, and one more player. So Vincent. So Neeraj secured one rank, Jacob ranked two, and Vincent ranked three. There are 6 rounds. It is clearly mentioned in 6 round, except Neeraj, other two were fouled. So 6 round has been left out. Now there are 5 rounds are there. It is mentioned that 1 and 2, Neeraj played the well, and for the second round he got the prize. It is a mention that for fourth round, Vijay, right? He make the fourth round. Who make the best one? Jacob. Jacob has make the best one. So right. So tell us, right? Vijay make the right best performance in which round? So fourth round is Jacob who got the position second.
फोर्थ राउंड तक ये हमारा कंडीशन था 1 2 3, बट उसने फोर्थ राउंड में अपना सबसे बढ़िया फेंका।
इसमें
जैकब जैकब ने लाइक अभी फोर्थ राउंड है तो उसने 100 मीटर फेंका रहेगा और इसने 90, इसने 80।
So I think there are some ambiguity in the problem. Just wait 1 minute. So look at in this problem, what is mentioned? Till fourth round, Neeraj was 1 and Jacob was third and Vijay was second. And at the last right, Jacob was become 2 and Vijay was third. So look at here, it means in the fifth one, the position has been changed. And so the third option, the third match, right, in which, right, this one, Jacob has played his test matches. That is round number 3. So please write answer is round number 3. Exact questions you will get it right once a response sheet will come. Answer is here round number 3. Why round number 3? Fourth is not possible. 1, 2 not possible. Fifth is the situation has been changed. There is a question of a right English aptitude. Antonyms they have asked, and they have asked right what is the antonyms of a protagonist, and that is a very simple right. We can use the antagonist only. A and T. Okay. So now we'll discuss some more problem. What is the maximum height of a full binary tree of a 23 node? Here the definition of a full binary tree, every node is full, right? It will have either 0 child or 2 children. So the correct answer is n minus 1 by 2, and 23 minus 1 by 2, the answer will be 11. 23 minus 1 by 2, and answer will be 11. So we have right already discussed. Now we have a clear problem available that there is a question is given of a pre-order traversal. So we need to find what is the position in a post-order traversal. Position of element in a post-order traversal per 60. So pre-order sequence is given 50, 25, 13, 40, 30, 47, 75, 60, 70, 80, 77. So look at everyone. In order is a sorted list. So we can directly construct the tree. We can directly construct the tree as follows. Fifty will be the root node, yes. 25, 13, 40, yes. So just to take the post order traversal of this. What is the sixth known? Or there was what is position of 16?
Position of 60 in the post order travel. Sorry, next start.
Position of a we'll just take the post order traversal. Take the post order. Post order will be 30, 13, 30, 47, 40, 25, 70, 60, 77, 80, 75, and 50. So here if you'll calculate, the position of 60 will be, so they have mentioned the position starts from 1 or 2, 1. So this element position will be 7. So that is a layman approach to solve this problem. This problem can be solved very smartly without constructing the tree. Because in pre-order traversal, 50 is a root node. So all the elements which is a less than 50 are part of a left subtree or part of a left subtree. 50 and 50 is a node. So you can directly count from a pre-order traversal 1, 2, 3, 4, 5, 6. There are 6 elements. Yes or no? The other will be the part of a right subtree. Other will be part of a right subtree. But right subtree root is a 75. Root is a 75. Yes or no? So anything less than 75 is a left subtree of right, and more than 65 is right. So 60 is less. Yes or no? So we have to count only left subtree. And in left subtree, the root will be of a right. The first element after 75, which is 60, which is a 60. Yes or no? But if you can compute right, so here, I think let's start some element. 1, 2, 3, 4, 5, 6. Yes. So its position should be 8, na? 1, 2, 3, or 50 will be that. So here this is the 5 elements and 2 elements here, and the position will be 7. Next problem. So look at here. In this case, L3 is definitely semantic error, right? Because it is a characteristic, it is not a integer. Now, if we talk about L2, it will create the problem for everyone, right? But here there is no issues, right? What is just only a right last right? A semicolon character is here valid character. It is not showing the end of the termination. What is happening in the first one? First one we have a missing right, close right pencil. So it is a syntax error. It is expecting right? What they will mention. They are expecting one right. So it is not a lexical error. So I'll go right for L1 will have a syntax error and L3 will have a semantic error. So we'll check right the exact questions also. There is a small problem of expectation of probability where there are 1 to 8, 8 integers. For 4 integer 1, 2, 5 and 7, probability is 1 by 6. And for other 4, 3, 4, 6 and 8, probability is 1 by 12. They ask what is expected number. Very simple. 1 by 6 into in bracket 1 plus 2 plus 5 plus 7 and rest right 1 by 12 plus 1 by 12 into 3 plus 4 plus 6 plus 8, and if you solve this equation you will get the corresponding answer as a 4.25. Now there is a question right in numbers. There is 1, 2, 3, 4, 15 incomplete binary search tree. Which node cannot be inserted? Such kind of problems, even if you remember honestly, this is nothing we discussed in the very last lecture. Last lecture, what we discussed, if we have 1 to 7, if we have 1 to 7. In how many permutation we can insert such that we can get the binary search tree? Here they are asking which cannot be inserted as a third one, which cannot be inserted as a third. And it is a complete binary search tree. So first you make the structure of it. Yes or no? 8 will be the root node. Yes or no? Now 1 to 7 will be left subtree. So here 4. And then it is a 2, 6, 5, 7. Yes or no? Sorry. 2, 6, 1, 3, 5, 7. Then here it is a 12, 10, 14, 9, 11, 13, 15. So third insertion, please remember. In the third insertion, an element can be inserted if it is at the second level or it is a third level or it is a any element which is at the first level, which is at the last level here, fourth level, that cannot be inserted as a third element. So here what they have mentioned? First they have mentioned 10. So 10 can be inserted as a third. I'll tell you how. First 8, then 12, and then 10. 2. 2 can be also inserted. 8, 4, 2. Now they have mentioned 4. 4 can be also inserted. 8, 12, and 4. 5. Now they have asked right about 5. 5 is at the last level. Yes, no? 5 cannot be inserted as a third element. Yes? So I think this question could be MCQ, right? MCQ problem. The correct answer is 5. 5. Okay? So you can understand, look at this tree, right? So now we'll try to get couple of more problems. So look at here. There are three problems are here.
दो ही लिखा है.
There are three problems are there. First, right, they have mentioned there is a two balls, one red color, another blue color ball. And they want, right, whenever we are picking one ball, so what we are doing, right, we are adding one more ball, right, of the same color and push them into the right bucket. They are asking what will be the probability that at the end of the second iteration, red and blue both balls will be same. That is the simplest problem. For the first ball, whatever you are putting, let's say if you take red, then you will have after first iteration two red, one blue. So in the second iteration, which one you should choose? Blue. Which probability is 1/3? If in the first iteration you choose in blue. So after the first iteration, you have two blue and one red. In the second iteration, you should choose red only, which is 1/3. So correct answer for that problem is a 1/3 only. Because after the first iteration, the two ball will be one color and one ball will be of the separate color. And if you want after the second iteration, both should be the same. You will have only one choice. In the second iteration, you will choose the ball, right? Color ball, which has a less numbered, right? So that is always 1/3. Sir, question. Child again will go for the next round. Yes or no? So again, there could be a parent or there could be a child. Parent will print. Parent will what? Print. Yes or no? Now look at here. For child, I is equal to 2. Again, it will continue here. I value will become 3. Yes or no? This is more than further. See, it will come out of the for loop. It will come out of the for loop. Yes or no? And last child will also what it will perform? Print operation. What it will perform? So the total number of a print will take place, right? 4 number of prints. How many number of print? So 3 for the parents and 1 for the child. So total number of print will take place 4 times. Total number of print will take 4 times. So you'll have 4 number of total what? Leaf node, and the number of leaf node will perform the. So total number of print will be 4. Okay. Sir, no. Now they have mentioned, like, I think options are, L2 complement is context free, that statement is always true. Because L2 is a regular. L2 is a regular. So there is only one option is correct. And L2 complement is a context free. L2 complement is a context free. Yes, no. Now what they are given, there is a 7 is right? Path. Path means 7 is nothing. 8 vertices path you have. Yes or no? And what they have asked? How many total number of a matching possible? How many total number of a matching possible? Yes. So what you can take here, right? 1, 2, 3, 4, 5, 6, 7. Yes or no? So you can have matching here are how many edges? This with one edge could be matching, two edge could be matching, three edge could be matching, and four edge could be matching. Yes or no? कितना edge matching मैंने बोला? One edge, two edge, three edge, four edge. Right, that's all. Right, four edge na? There are yes. Giving value of then four edge test together. There are 8 vertices. Yes, four. So far one edge. One edge. How many possibility you have matching? 7 matching. How many matching? Doubt I guess. For a single vertex, F1 is a 1. You are not taking any edge. F2 is equal to 2. And for n number of vertices, the series will be Fn is equal to Fn minus 1 plus Fn minus 2. So you can calculate now slowly. Third will be like 3, 4 will be how much? 5, 5 will be 8, 6 will be 13, 7 will be 21, and 8 will be 34. Answer. Good.
Um, on a mic.
So total there are 34 matching. 60. Equation after the 2,105.
I got this. On camera.
So look at here, this function, it is a returning the value 1 plus log star n. What it is returning? Because if you take n right, then it will compute the value of a log n. So this is the 1 plus log star n. So this value is 5. So log star n is a 4. So for which value of n, right, log star n is a 4. So n will be 2 raised to 16. N will be 2 raised to 16. Okay. This will have a two answers correct. One is a path of a k plus 1, another one is a click of a size k. Click of size k wide should be correct. If you have a k vertex complete graph, then right, the independence number you have to take at least one vertex up there, right? At least exactly you have to take one vertex there, right? Not more than one vertex is possible. So the rest of vertices, right? Whatever one vertex you will take, other vertex will be part of a vertex cover. Next question. So now we'll discuss some other problem memory based. Yes. So in this problem, originally S generate equal number of A and B generate equal number of A and B, A generate either A twice of B or 3 by 2 times. So it means number of A is greater than B and number of A is less than twice of number of B. So answer goes to C and D in this case. Next problem. near algebra, where they are given, right, we have a matrix of a size at, please. We have a matrix that is quotient of n greater than 1, n cross n. And they have given, we have one null space 0, 1, 0, 0, 0. Transpose is element of a R raised to n. So they mention the determinant is 0. That is a correct, right? Now, rank is 1. No, rank need not to be 1. Rank can be 1. Rank can be greater than 1 also. Determinant is 1. Determinant is 1 is false because determinant should be 0. Greater are 2 non-zero vectors in null space. If n is greater than 2, then this statement is true. But if n is equal to 2, then we need to only one actually non-zero vector. So correct answer goes to determinant should be 0. Next problem. Next. So there are two problems. In one problem, they have asked, right, if we have a n cross n matrix, then what could be the maximum multiplicity of an eigenvalues? Simple answer is identity matrix, where, right, the lambda is equal to 1 repeated n number of times. So the maximum possible value could be n. Then there is a one program is given to count the total number of node, and they have clearly mentioned that is a non-empty linked list. So that is actually important point. If it is empty linked list, then you have to check if head is equal to null, then return 0. But it is non-empty, so head cannot be null. So if head next is a null, then return 1, else return E2. So what is E2? Means there is element, so 1 plus, and now you need to move to the next element. So E1 will be head next is equal to null, and E2 will be 1 plus 1. Again, you have computing what header next. So these are the two problems. तो मैं बोलूंगा तो इसलिए there is a problem about the data dependency hazard. Which type of dependency may cause hazard? So the answer is RAW dependency. We have already discussed. WAW dependency and WAR dependency cannot be region of a hazard. They can be region of a hazard if it is a out of order execution. So correct answer is RAW. Next problem, that is very simple problem. It comes in deadlock, right? So there are n number of 5 processes. Each process may request maximum 2 instance of resource, and that is also one by one. So what should be the instance of resources which ensure that system will be deadlock free? So simple formula, n into k minus 1 plus 1. So 5 into 2 minus 1 plus 1, that answer will be 6. There is a problem given regarding to the TLB, page table, and cache memory. And it is mentioned that cache is physically tagged, that is mapped with the main memory. So they have asked what is not possible. They mentioned TLB is hit and page table miss. That never happened. Whatever data is in TLB, that must be in a page table. Another problem they mentioned, TLB hit, page table miss. TLB miss, page table miss. That is possible. But when page table is missed, we are invalidating the cache entry. At that point of time, cache hit is not possible. So these two entries cannot be possible at any point of time. So now we'll discuss some more problems. According to the deadlock, which statement is a false. Bankers prevent deadlock, that is incorrect, that is for safety algorithm. It is incorrect statement. Prevent deadlock by no hold and wait, that is a true. This is not an answer. Bankers is a safe, right? But not deadlock, that is true. And assign age process to resource, that is incorrect. Right? Assign age from resource to the process. So here, correct answer is A and D. There is one problem regarding to the DMS, regarding to decomposition, dependency preserving. So they mention in one NF, dependency preserving one is always. So look at what is concept. 3NF, up to 3NF dependency preserving always possible, and BCNF is not always possible. So always DP for 1NF, that is true statement. Always, right? With always not for 2NF, that is false. Always not for BCNF, that is also true. And always for 3NF, that is also true. So there are three correct answers. Always dependency preserving for 1NF, always not for BCNF, and always for 3NF. These three statements are true. Always not for 2NF, that is a false statement. So now we'll find few more problems. one tuple relation related question. R A comma B and S is X comma Y. What they have mentioned, we are returning U, right? And they have mentioned for some P, some W, UV is element of R. It means U is a and B is a B. And VW is element of a S. It means X is a V and Y is a W. So what actually they want, P and X should be same. So whenever you do the natural join operation, you make sure that R dot B is equal to S dot X. That is the key point. And since you are returning U, which is nothing, it is a of R. So it is a natural, right? Pi of A, S natural join R, where R dot B is equal to what? S dot X. That is a correct answer. Okay, right. There is a sliding window protocol problem where bandwidth was given 100 kilobits, frame length is 1000 bit, and propagation delay is 100 milliseconds. So we have evaluated TF, that is at 10 milliseconds. They have asked what should be the window size that the utilization is 100%. So simple formula WTF divided by TF plus 2TP should be 1. So here W has come as a 20 bar. Next. Apes. So there is a problem, right, for a subnet and supernet related problem. So initially we have an IP address given 202.16.0.015 and they want to devote for a 6,000 hosts. So 6,000 means how many bits? 13 bits, right? So our subnetting will be up to 19 bit. Now they ask, right, which particular bit we can provide it. So first they mention 0. Yes, that can be given. Then 17.64. What does it mean? The last bit they have given one, right, because earlier it is 15. So 16th bit. And then they have taken a 3 more bits. Yes or no? So they can do 3 bits. 3 bit means what? 128, 64, 32. So there they have make 64 one. That is also fine. They can make 32 one. That is also fine. But they cannot make 24 one because it is more than 19 bit. It is a more than 19 bit. So correct answer is a B and C. Next. So there is one problem related to the HTTP connections. So there are two options correct. One, in a single connection, multiple objects from the same server is correct. Different server is wrong. And when they are mentioning a single connection, multiple object download in a single RTT pipeline, that answer is a correct also. And once they are saying multiple web pages in a single connection, that is the wrong option. So there are two correct answers. Next. there is a one problem of a congestion control. They have given right threshold value is quite high value, 10 to the raise to 4. Start right one segment, one RTT is 1 milliseconds. They have asked the 2000 segment in which right when it will transfer. So the simple formula is before ith, you will send the 2 raised to I minus 1. You will send a 2 raised to I minus, you can feel it. Before 1 millisecond, at 1 millisecond, you have sent only one segment. 2 raised to 1 minus 1. Right? After 2 RT, you have sent the 3 segments, 1 and 2. Right? So at t is equal to 10, you have sent 2 raised to 10 minus 1 segment, which is 1023. Now 2000, which is a less than again further right 2 raised to 10. So that you are sending from before right after 10 but before 11. So correct answer goes to 10 to 11.
C.
there is a magnetic disk problem where it is a mention, right? The important part is here. Adjacent, right? If you are moving to the track, then actually seek time is 1 millisecond. Currently, you are at the 0. So you have to move 5, you have to move 10, 12, then you have to move 7. So 0 to 5, 5, 5 to 12, 7, and 12 to 7 again 5. So 5 plus 5, 10 plus 7, 17. And at one track is 1 millisecond. So total seek time is just 17 milliseconds. Now they mention on each track, you are looking at 10 random sector. It means that average latency is applicable for each sector. So that is half of the RT, and the data which is given, the rotational time is a 4. So half of the RT is a 2. So what happened? 10 into 2, 20 for one track. So such 3 track. So that is a 30 milliseconds. Sorry, 30 into 2, 60 milliseconds. Now, reading the data, they have mentioned 0.01 milliseconds. There are such 30. So 30 into 0.01 is 0.3. So correct 17 plus 60 plus 0.3, 77.3 milliseconds. process scheduling related questions where there are 5 occurrences of A and 5 occurrences of C, and A and C are coming alternatively. So the A arrival time is given 10, 20, 30, 40, 50. B arrival, C arrival time given 11 tables, right? 11, 22, 33, 44, 55. All A will take a 6 unit of time, C will take a 8 unit of time. And they ask FCFS what is the average turnaround time, right? What they ask average? Average waiting time. So the average waiting time has solved and right, that is 9.5. Next. There are K-map problem quite easy. So it has a more than one options correct, right? There are 2 options correct for this K-map problem. And that is a simple one, right? Hmm? Hello, please. There is one problem of a digital gate, which actual answer is a XNOR gate. So you can answer in 2 different ways. Either P bar XOR Q या P XOR Q का whole complement. Such kind of questions has come in gate PYQ many number of times. Gayatri, correct? Next, visitor. So here if you look at right, there are minus 52 and plus 76. If we are adding them or subtracting them, there cannot be overflow. That is true. Either what happened, one is positive sign, another is a negative sign, then it can be overflow. Now what happened, right? Minus 52 and plus 76. If it is minus 76, then it is a 120 minus 128. If it is 2's complement, then there are no overflow. But sign bit, there is a overflow. Yes or no? And in the exactly same way, so x minus y and y minus x will give overflow. Addition of both will not give the overflow. Next. Floating point representation, which answer is directly we are writing answer 035E8. Next. is the grammar, right? AS, BS slash BS slash epsilon. So here there are three options are correct. One, AB will have only one parse tree. ABB will have a two, and the grammar is ambiguous. These are the three correct answer. Next. Closing problems right after set one, and once we'll get some more problems of set one, we'll update in PDF and share today itself. And please everyone remember, set two problem will start discussion after 7 p.m. today.